Okay, so you've gone AWS Direct Connect,
Right.
right? Makes sense. Maybe it's the speed you need. Maybe it's that seamless access to all things AWS. But now you got to make sure that connection is seriously bulletproof. We're talking that gold standard 99.99% uptime.
Yeah, no doubt about it. That kind of reliability, that doesn't just happen, you know. It takes planning, redundancy, and really understanding how to get the most out of AWS Direct Connect. The good news is Amazon's got your back with a guide for exactly that.
They do. They really do. And that's what we're diving deep into today. Amazon's active and active passive configurations in AWS Direct Connect guide. Brand new, just out September 2023. But before we get into the nitty-gritty, let's talk about why this even matters. Anyone listening who's using Direct Connect, why should they care about making it resilient?
Okay, so think of it like this, okay? AWS Direct Connect, it's basically building a bridge, right, between your network and the AWS cloud. Now imagine for a second that bridge is the only way you can get to your critical stuff, resources, data, you name it. If that bridge goes down, even for a little bit, we're talking major impact.
Oh yeah, for sure. Lost business, customers tearing their hair out, everyone scrambling, trying to figure out what went wrong. Not a pretty picture.
Exactly, you got it. That's what resiliency is all about, dodging those situations completely. It's peace of mind, you know, knowing that even if one part of your connection decides to take a nap, you've got backup, fail-safes in place. And that's where these active and active passive setups come in. They're all about making sure that bridge to AWS is rock solid.
Gotcha. So instead of one single point of failure, you're building in multiple paths, multiple ways for your data to get where it needs to go. Makes a lot of sense. Let's unpack these setups a bit. The guide actually uses a really helpful analogy to explain active, talking about lanes on a highway.
Perfect example. So with an active configuration, you've got multiple connections to AWS, and they're all actively sharing the load of your data, kind of like cars spread across those highway lanes. What this means is, if one connection decides to take a nosedive, it's not a complete standstill. Traffic, it can just scoot over to the other lanes, you know, minimize that disruption.
Right, it's like your data has a detour already mapped out, so even if there's a little slowdown, things keep moving. But it's bigger than just having a spare connection, right? The guide stresses this idea of redundancy at every single level.
100%. You could have a backup connection to AWS all set up, but what if the router in your data center decides to call it a day? Or there's a problem with one specific device? See, the guide, it's pushing for this whole holistic approach to resilience. Redundancy in your AWS locations across different AWS locations, even down to your own data centers and those individual devices, it all matters.
You're basically building your connection to AWS as if you know something's going to go wrong, planning for the worst case scenario.
Exactly. You hit the nail on the head. And when you're that prepared, that's when you can actually hit that 99.99% uptime. That's less than an hour of downtime over an entire year.
Now, those are the kind of numbers that'll make a CTO sleep well at night. We do have another setup to cover, though. Active-passive. This is where that whole backup quarterback idea comes in, right?
Bingo, you got it. So active-active, it's all about sharing the load equally. Active-passive, on the other hand, it's about having that designated backup, ready to jump in if the main connection goes down. A different strategy, but same goal, super high availability.
Okay, I'm with you. So say one connection is our star player, handling the majority of the traffic. The other one, that's the understudy, practicing hard, ready to go, but not actually on the field unless absolutely necessary. When would someone actually choose to go with that kind of setup?
Active-passive, it can be a really solid choice if you've already got a primary connection that's really strong, maybe cost-effective, or it just ticks all the boxes for your performance needs, and you only want that backup to kick in for those, oh no, everything's on fire situations.
So you're not always paying for two high-performance connections. Just got the one workhorse and a trusty backup waiting in the wings. But does that mean with active-passive, you can ease up on the redundancy?
Not a chance, no way. The guide is super clear about this. No matter what, active-active or active-passive, you still got to eliminate those single points of failure throughout your whole setup. That means multiple locations, different paths, redundancy at the device level, the whole 9 yards. We're still going for that same holistic resilience.
Got it. So both setups, they're all about redundancy. They just have slightly different game plans. I am seeing this term VIF popping up everywhere in the guide, though. What exactly are VIFs, and how do they fit into all of this?
VIF, it just stands for virtual interface. Think of them like on-ramps and off-ramps, connecting your traffic to AWS. You've got public VIFs. Those are for your public AWS services, things like S3. Then you've got private VIFs, and those are the ones that connect to your own stuff inside your virtual private cloud, your VPC.
So public services, private resources, you pick the right VIF for the job. Makes sense. But how does your data actually figure out where to go? Like which VIF to use, which connection to prioritize? How does it all work?
That is where things get really interesting, and it all comes down to this little thing called BGP.
BGP, the Border Gateway Protocol,
Quietly.
right? The language of the internet, if I remember correctly.
Know it. It's how all these different networks talk to each other, figure out the best routes, and make sure your data ends up where it's supposed to be. And within BGP, we've got these tools like local preference, AS paths, and MED values that we can use to fine-tune those routes, kind of like setting up the navigation preferences on your GPS.
Okay, now I'm really intrigued. We've got our connections, our VIFs, and now this whole BGP GPS system. How do we use all of that together to create a truly resilient AWS Direct Connect setup? Let's dive in, starting with that active-active configuration. Okay, active-active, right? Multiple connections, all sharing the load, working together. It's like having, I don't know, multiple engines on a plane or something. Even if one gives out, you're still good, still flying. So say you've got these redundant connections all set up. How does AWS actually know how to distribute all your traffic across them?
That's where those BGP settings we were talking about, those become key. Remember local preference, one of those knobs we can tweak to kind of steer the traffic.
It's like, what, setting the priority level for each route?
Exactly, spot on. With active-active, we want to make sure all our connections, they've got the same local preference. We're not trying to play favorites here.
So equal opportunity routing for all the data, no special treatment.
Exactly. Give those data packets options, right? And this is where the guide gets into advertising prefixes.
Right, those prefixes, they're basically like, what, digital addresses for different parts of your network?
Right, you got it. And in an active-active setup, you want to advertise those same prefixes across all your direct connections. It's like sending AWS a message like, hey, all these connections, they can all get you where you need to go.
So even if AWS is seeing multiple paths to the same place, it knows they're all equally good because you've advertised the prefixes consistently across the board.
100%. It all comes back to clear communication, making sure AWS has the full picture of what your network looks like. And when you combine that consistent prefix advertisement with those balanced BGP settings, that's how you create a really solid, resilient traffic flow.
Okay, so we've got the connections, we've tweaked our BGP settings, we're advertising prefixes, like there's no tomorrow. Anything else we got to keep in mind for that bulletproof active resilience?
Don't forget those LAGs, Link Aggregation Groups, remember? We can bundle up multiple physical connections, combine them into one logical link.
Right. It's like taking a bunch of smaller ropes and braiding them together to make this super strong cable. Right.
And with active-active, those LAGs, they just add another layer of fault tolerance. Even if one of those physical connections within the LAG decides to go on break, the others, they can just pick up the slack. No problem, no traffic interruptions. It's like having built-in redundancy at the cable level itself.
So with active-active, we're talking redundancy on top of redundancy connections, locations, even down to the actual cables. It's a pretty comprehensive approach. But I got to ask, are there ever any downsides to going all in on active-active? It almost seems too good to be true,
Well, like anything in tech, there are always going to be some trade-offs. Active-active, while it is super reliable, it can be a bit more, let's say, involved to configure and manage than active-passive. You're basically conducting an orchestra of traffic across multiple paths at the same time. It really takes a good understanding of BGP and some careful planning up front.
So it's not something you just jump into without really knowing what you're doing. Yeah. You need the right people, the right expertise on your team to make active or active really shine.
Absolutely. But for those organizations where downtime, it's just not an option. Those places where even a few minutes offline can cause a major headache, that investment in active-active, it can be worth its weight in gold. It's the gold standard for a reason.
Makes sense. Okay, let's flip over to active-passive for a bit. So if active-active is all about distributing the load, active-passive, that's more about having a solid backup plan, right? Like a plan B.
You got it. Think of it kind of like having a main data center, your primary one, and then a separate disaster recovery site. That's where everything's running, day-to-day operations. But you've always got that secondary site ready to go just in case.
Okay, so with active-passive, we've picked one direct connection, that's our star player, and the other one, that's our backup, on standby. But if that secondary connection isn't actively handling traffic, how do we actually make sure it's ready to take over at a moment's notice if it needs to? So our primary connection, it's all prepped, ready to roll, but what about its trusty sidekick, that secondary connection? How do we make sure it's not just, sitting there twiddling its thumbs, but can actually jump in and seamlessly take over if the primary one decides to take a break.
Well, that's where, once again, our BGP settings come in. Remember earlier when we were talking about using local preference to create that, equal opportunity routing in an active setup? Well, with active passive, we're going to use those same settings, but this time we're going to be a little more stage address with it.
Strategic, I like the sound of that.
Yeah.
So instead of treating all paths the same, we're going to give our primary connection a little, I don't know, a little VIP treatment.
You got it. We can use that local preference setting to give our primary connection a higher priority, make it the more attractive route for traffic. Think of it like, I don't know, slapping a fast lane sticker on all the data heading towards that connection.
So AWS is always going to choose that primary connection unless it's down for the count. Then and only then, it goes with the secondary as that fallback option.
Precisely. And to really fine-tune this whole failover process, we can use something called AS path prepending. Imagine for a second, okay, you've got two ways to get to the same place, right? One route, it's direct. The other one, it's got a few detours along the way.
The direct route, that's always going to be faster, right?
You know it. So with this AS path prepending, we're basically adding those metaphorical detours to the route advertisement for our secondary connection. It's not actually making the connection slow or anything, but it makes it look less appealing from a routing standpoint.
So AWS sees that primary connection. That's the nice, fast, direct route. And the secondary, that's the one that looks a bit longer, not as efficient. Only goes for that secondary pass if the primary one is out of commission.
Exactly. It's all about setting those routing preferences, making it crystal clear without actually impacting the performance at all. And one thing the guide points out, with those public VIFs, we can get even more specific with our prefix advertisement for even more fine-tuned failover.
Now, we did mention public versus private VIFs earlier, but just as a refresher, what's the main difference and why does it even matter in an active-passive setup?
Sure. So just to recap, public VIFs, those are your connections to public AWS services, things like S3 or DynamoDB. Private VIFs, those are for getting to your own private resources inside your virtual private cloud, your VPC. So in an active-passive setup, you might decide to advertise a wider range of prefixes on that primary connection, make sure all those services are highly available.
Okay, so the primary connection, that's like the main gate to your AWS world, handling everything public, private, the whole shebang.
Right. But on that secondary connection, you might just advertise the prefixes for your most important private resources, the ones that absolutely cannot go down.
So if that primary connection takes a nosedive, that secondary connection is ready to step in, make sure you can still access those vital private resources. Maybe not every single public service, but the critical stuff is covered.
Exactly. It's like setting up this tiered failover system, making sure that even if you have to switch over, those super important applications, they stay up and running.
Sounds like active-passive gives you a lot of flexibility, then finding that balance between cost and how much risk you're willing to take on.
100%. And that's a really important point the guide makes. There's no magic formula, no one-size-fits-all answer when it comes to active-active versus active-passive. It all boils down to your specific needs, your budget, how comfortable you are with managing these, let's be honest, sometimes complex configurations.
Right, going to weigh those trade-offs. Active? Active, yeah, it's maximum resilience. But for some organizations, that might be overkill. Active-passive gives you that dedicated backup plan. Might be a better fit for those who don't need absolute 100% uptime and want something a little more budget-friendly.
Exactly. Find that sweet spot between cost and making sure you're protected. But no matter what you choose, those core principles of redundancy, those still apply.
For sure. Multiple connections, different locations, those L's we talked about, those are all crucial pieces of the puzzle for a truly resilient AWS Direct Connect setup. Active-active, active-passive, doesn't matter, those things matter.
Absolutely. Couldn't agree more. And this is where having the right team in place, people who really understand these concepts, who can put it all together the right way, that becomes super important.
So true. You could have the most amazing, robust network architecture in the world, but if your team doesn't know how to manage it, you're not going to get that bulletproof connectivity you're looking for. Got to invest in the technology and the people to make it all sing.
Couldn't have said it better myself. Resiliency, it's a journey, not a destination.
Well said. So there you have it. We explored those active and active-passive configurations, dove into the world of BGP settings, tackled those VIFs. You should be feeling ready to make those big decisions about your own AWS Direct Connect setup. Until next time, may your connections be strong, your uptime sky high, and your data flowing smoothly.